Namaste and welcome to Apna Gurukul Maths. Today we'll be dealing with the second video of the chapter triangles. In the last video, we have discussed about SAS and AAS rule of congruence. We will try to study in today's class a little bit about properties, a few important properties about the triangles. Now, so properties of triangle which we are going to study right now, and we will be proving it as well. We have already studied about this property, but we have never proved it. So this in this particular video, the major thing which we are doing is proving it. So the property says, which is also theorem 7.2, angle opposite to equal sides of an isosceles triangle are equal. For example, as you can see in the figure, there is an isosceles triangle given, triangle ABC, and it is given that AB is equal to AC. And we need to prove that angle BCA, that means BCA is this angle, and angle BAC, these two angles are equal. This is what we have to prove. So how will we prove? We will first try to prove that somehow they are congruent, and we will draw a line. Okay, we will construct a line BD, which is an angle bisector to angle B. Okay, so we first thing we'll do is we'll construct an angle bisector of B, which is BD. Now once we have done that, we will try to show ABD is congruent to BCD. After we have shown the congruence by CPCT, we can say angle A equals angle C. I hope that how are we approaching the problem is clear. So in triangle, so first we have constructed an angle bisector from B to D, and obviously D is intersecting AC. Perfect. So in triangle ABD and triangle BCD, what do we observe? That angle ABD is equals angle CBD. Yes or no? Because we have drawn an angle bisector, then AB is given to be equal to AC. That is already given. And then as we observe that BD is equal to BD. This is common side. So what do we observe right now? That we are actually using side, angle, and then side. Same over here, side, angle, and side. So SAS criteria, using SAS criteria of congruence, what do we get? Triangle ABD is congruent to triangle. What is corresponding to ABD? A is corresponding to C. Yes or no? So C and BD is corresponding to BD itself. So CBD. I hope that makes sense. Yeah. So triangle ABD is congruent to triangle CBD. So by CPCT, we can say that angle DAB or BAD is equal to angle DCB. And that is what we wanted to prove. That means these two angles are equal. So we can clearly say that, hence the proof. That is what the first property of triangle, which is very important, it is talking about. Let us talk about the converse of this theorem. The sides opposite to equal angles of a triangle are equal. Now, it's already given that angle A equals to angle B. We need to prove that AB is equal to AC. I hope the question is clear. Once again, we'll do the same construction from angle A. Sorry. We will draw an angle bisector which is intersecting the opposite side BC at D. That means we will get angle BAD is equals angle DAC. Why will we get it? Because that's how we have according to our construction. Or you can simply write AD is a angle bisector of angle A. Perfect. Then as you can see, angle ABD is given to be equal to angle ACD. This is given, and at the same time AD is equal to AD. Yes or no? That is common side. So which property are we using? Which rule are we using? We are using angle, angle, and then side. Angle, angle, and then side. We are not using ASA. We are using AAS criteria of congruence. So we can say that triangle ABD is congruent to what is the congruent sign? Triangle, congruent to triangle. Now A is corresponding to A, B is corresponding to C, and then D is corresponding. So we have written according to the corresponding values. Now what does this imply? As we already discussed in last video, if you want, you can just see the link and see the first video of triangles. What are the corresponding parts? So AB will be corresponding to AC. Yes or no? So AB is equals to AC by CPCT rule. That is what we wanted to prove. Hence the proof. So we have learned two new properties of triangle. So we will try to solve now problems regarding those properties. Suppose we have example number 4 as given over here. So in triangle ABC, the bisector AD of angle A is perpendicular to side BC. Show that AB equals to AC. We need to show that AB equals to AC. And obviously, if they will be equal, triangle ABC will be isosceles. So what we will do is we will consider ABD triangle and ADC triangle. As you can see, this is angle bisector. So this angle is already equal. This is 90 degree already given. AD is common. So angle side angle criteria, we will be able to, now you cannot use AB equals AC because that we have to prove. That is what we have to prove. It's not given. Okay. So by SAS criteria, we already have three corresponding parts which is satisfying one of the criteria which we have read. So that implies triangle BAD is congruent to triangle CAD. Again, BA is equal to CA by CPCT. BA equals CA by CPCT. So, since two of the sides of triangle ABC is same, they will be congruent to uh, triangle ABC is an isosceles triangle. I hope that makes sense. Let's move on to example number 5. It is a little bit similar, but a little more thought process is involved over here. Okay. So over here, the question says EF are respective. E and F are respectively the midpoints of equal sides. Now it's already given AB is equal to AC. E and F are midpoints of equal sides AB and AC of triangle ABC. So we need to show that BF, that is this side, is equal to EC, this side. Yeah. So how will we show that? So in triangle ABF, so ABF is this triangle and ACE is this particular triangle. We have these two triangles we will consider. Okay, I have drawn it separately as well. Now angle A is common with angle A. AB is given equal to be ACE. Now what else? What else? What can we use? We have to prove that BF is equal to EC. Now, if we are able to prove that they both are congruent to each other, we are done with our proof, right? So what else have we taken? AF equals to AE. Now, how come are we able to say AF equal to AE? Because AB is equal to AC if we make half of two equal things. What is happening exactly? Since AB equals to AC. If I take half of AB, will that be equal to half of AC? Absolutely, right? Now, since E is the midpoint, half of AB is AE. Since F is the midpoint, half of AC is AF. That is what we wrote. So AF is equal to AE. Now the triangle ABF will be congruent to triangle ACE, and that is how, according to CPCT rule, we will get BF equals to CE. Is that clear? Fantastic. So sorry, BF is this, right? BF is equal to EC, and that is how we are able to prove it. I hope that makes a lot of sense. Then we have example number 6 in front of us. So example number 6 says, in triangle ABC with AB is equals AC. Again, this is given. Now using the theorem, we can say that angle B is equal to angle C as well. Angle B is equal to angle C. Now D and E are points on BC such that BE is equals to, now BE is equals to DC. That is a little bit twisted question. Now we need to show that AD is equals to AE. AD is equals to AE. So if we somehow prove that triangle ABD is congruent to triangle AEC, we are done with the proof by CPCT. We can say AD is congruent to. So AA is equal to DA. So what do we take? We consider triangle ABD and ACE. And then AB is given to be equal to AC, that is very clearly. With the help of theorem, we can say that angle B equals to angle C, that is also done. Angle opposite to equal sides are equal. Now, can I say that BD is equal to EC? How can we say that? Observe. It is given that BE is equals to EC. Now, can I subtract same thing from both sides of the equation? Can I do that? In an equation, if I subtract the same thing from both sides, that does not change the equation, right? That is what I'm doing. Now I removed this particular side from both of them. So BE minus DE will be BD, and DC minus DE will be EC. Sorry, I'm sorry. This must have been not EC. This must have been DC, because it is given to be equal to CD or DC. Yeah, so this is what we got. So side of these two triangles are equal, and hence we can show that triangle ABD is congruent to triangle ACE, and as you can observe, AD and AE are corresponding sides. That is how we say that AD is equal to AE. With this, we are done with sweet, beautiful, small proofs about some of the properties of a triangle. And these two properties we have been studying, but we have never looked at the proof, and we looked how do we apply in proving about the congruence of triangles as well. I hope this video was very much informative and you learned something new. If you found this as useful, you can share it to one of your friends who might be looking for this particular video. See you in the next video. Until then, keep smiling. Jai Hind.